Good morning, it's me, Mr. Truman, back for another video in geometry. Today we are going to be looking at angle side angle, another theorem having to do with congruence in triangles. So we're going to be looking at two actual theorems. So the first one I'm going to jump right into is called angle side angle. And once again, we are still trying to figure out whether or not we can prove without any doubt that two triangles are congruent. And this rule here that we're going to look at, this theorem, is called the angle side angle. And it says that if two triangles have two sets of angles that are congruent and the included side between them, meaning right between the two angles, the included side is congruent, then the triangles are congruent. Okay, so our first example says, is triangle WXY congruent to VTU? So what I didn't say so much in my last video that I really need to go over in this video is when you start these problems, one of the first things you always need to do is try to map out what they're asking you to compare and then make sure that the marks are going to match up. So as I look at WXY, the pattern, W is an angle that has no congruent marker, X has one, and Y has two congruent markers. So I'm just going to kind of recap that with the other one to make sure that I follow the same pattern. There were no marks, one mark, and then two marks. So let's look at VTU, and following that pattern, V has no marks, one mark, and two. Okay, so it looks pretty good because the pattern seems to hold, and I see the marks are approximately, it looks like everything's in the same spot. So now I have to just lay out my, the information I have. So I'm going to start with what I see, and by looking at my first example, I see that angle X is congruent to angle T. And then on the next one, I see that I have a segment, so this is an angle, and then I have a segment connecting here, so I've got XY, the segment, is congruent to TU. All right, and then the last thing I noticed is that I have angle Y, and it is congruent to angle U. All right, so when I sum that up, and we might want to mark this. I saw this little trick that I really like. I got this from another teacher. They said, make sure the kids mark it. So like if you mark it, we have an angle, then we have a side, and then an angle. So just like here, we have an angle, a side, and an angle as I put them in order. And that shows me that the triangles are congruent. So we are, yes, congruent by what's called the angle side angle theorem. Once again, two congruent angles and the included side between them as being congruent. All right, and our second example, a little bit different style. This time we have a little less information. Oh, I forgot to write something down on this one, so I'm going to correct that real quick. I meant to write this, no biggie. All right, so on this one here, it's asking us if ABC is congruent to EDC. So again, I want to map out any information. I have A to B to C, so A has one congruent mark, B has nothing, and then C is right here in the middle. So I have one, nothing, and then kind of in the middle. So when I come over here to EDC, I've got one, nothing, and in the middle. So it looks like the pattern's holding up. I just got to make sure that I have all the information. Now remember, this is called angle side angle, and right now I only started with a set of angles and a set of sides. And if you've watched my previous video, you know that one of the things that we talk about is sometimes there's information there that isn't so plainly given to us. We have to remember other things that we learned in the year. So hopefully right now you're thinking about the fact that these are two lines that intersect. So automatically, even though that they didn't tell us this, we're supposed to infer that they have vertical angles. So now it's time to put our case together and find out, are they congruent? Do they meet the requirements of angle side angle? Well, it really looks like it because I see an angle, I see a side, and I see another angle, and that side is included. It's between the two angles. Same thing goes over here. So now what I want to do is just simply write down what I know, the facts, and I know that for a fact that A is congruent to E. I know that AC, the segment or side, is congruent to EC. And then I just went over that whole thing about the vertical angle. So the vertical angle in the middle is congruent. But because that vertical angle is shared by both triangles, I can't get away with just doing the one letter name. I gotta use all three letters. So on that last one, let's call this one, we'll start here, we'll say ACB. So angle ACB. And then I want to match that. I always like to keep my order. It helps me keep myself organized. So I went A to C to B. So now I'm going to say E to C to D. And so I look at that, and again, if I do like I heard from a colleague, maybe if I'm writing it down, I have an angle, I have a side, and an angle. Angle, wrong one, side, and an angle. Kind of spells it right out for me, ASA. So these are congruent. I'm gonna say yes, by ASA. Oop. All right, and that takes us to our next theorem that we're going to look at, and this one's called angle side. And it basically says that if you have two consecutive meaning one after another, two consecutive congruent angles followed by a congruent side, then the two triangles are going to be congruent. So let's look at this picture here. I've got kind of two triangles drawn that are oriented a little bit differently. And I'm doing that only for one reason, and that is to get us used to mapping them out. So my question says SRT congruent to FED. So let's map out SRT. S starts up here where I see two congruent marks for the angle, R where there's one, and T where there's none. So 2, 1, none. Then over here I got FED. 2, 1, none. All right, it looks like they're oriented now the same way, so I can tell that I think I'm looking at two things that are going to be congruent. I just got to write down the information. So I'll start with, I see that angle S is congruent to angle F, and angle R is congruent to angle E, and ST is congruent to FD. So when I write all that down, and if I do that little label there, I've got an angle, and a side. AAS, angle, S. So it looks like they're congruent. So I'm going to say yes, congruent, and it's going to be called the angle side. All right, my last example, just one more to go. I just want to go over this one last example that has to do with angle side. And again, I'm kind of drawing on something that we have a hard time seeing, because whenever it's not presented to us and just kind of gift wrapped, if you will, on the information, and we have to dig a little bit, sometimes we choose not enough information as a choice on like a test or on an assignment. So let's look at this one more time before we get started. We have ABC, ADC. So I started A, which has 2 congruent marks, B, which has 1, and C that has none. Now I look at the next one, A, which has 2, D, which has 1, and C that has 1. Looks like they're situated the same. So it looks like everything's there, but I don't see 3 pieces of information. So I've got to figure out what's missing, because something's missing. I need to have 2 angles and a side. And the missing piece of information is the fact that they are sharing a side. And we don't normally mark that because it's a shared side, so we don't mark it with a symbol, we don't mark it with a congruent mark, but we do know that this is a fact. So you're just gonna have to let me put this here just so that we can see it. And that's because that's a common side. We call that reflexive, meaning it's shared by both parties. So this one and this one both share that side. That is a reflexive segment. But back to where I'm going to list my information. I see that angle B, I'll start with the easy ones, is congruent to angle D. The angle up at the top, like we talked about, is being shared. I don't know, I can't just say angle A because I wouldn't know if you're talking about that one or that one. So I got to use a 3-letter name on that. So I'll just start out here at the corner and say BAC is congruent to, and then I'll do the same on this side, start out at the end, DAC. And then the last thing I know is that AC is congruent to AC. And if I do that little label like I learned about, I really like that. Angle, angle, side, angle, angle, side. AAS. So they are congruent by all right, well that pretty much sums up that these last two on here. We'll probably be coming back later on to do the ones regarding right angles, but for now we have covered, just so we're clear, we have had side, 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 angle, angle, side, and angle, side, angle. I hope this works for you. I hope this gets it all done, and I'll see you soon.